A student can earn an A in algebra, know every formula needed for an AMC 10 problem, and still have no idea how to begin. That does not automatically mean they need more math. School problems usually tell students which toolbox to open. The chapter is quadratics, so they expect a quadratic. The homework is trigonometry, so they look for a trig identity. A MC10 removes those labels. Now the student must recognize the hidden structure, choose an efficient route, decide whether the problem is worth doing now, and execute under time. Those are different skills. In this video, I will show you 4 reasons a strong math student can underperform and a simple audit you can use on the next practice set. Let's look at a quick example. Compare 48 times 52 with 50 times 50. One student multiplies both products. Another notices that both pairs sum to 100, and numbers closer together produce the larger product. Both students can get the correct answer, but one route takes longer and creates more opportunities for arithmetic error. Contest mathematics rewards the habit of looking for structure before committing to computation. That habit is trainable. Sometimes the student genuinely lacks a concept. Maybe modular arithmetic is unfamiliar. Maybe a geometry relationship is missing. Maybe counting, probability, or number theory has not been studied deeply enough. That is a real content gap, and it needs instruction followed by targeted practice. But content is only one possible cause of a wrong answer. If you prescribe a new chapter every time, you may spend weeks treating the wrong problem. Reason 2 is recognition. Recognition means the student knows the idea once someone names it, but does not see that the problem is asking for it. They understand complementary counting after the solution says, count everything, then subtract the cases you do not want. They understand symmetry after someone points out the equal pieces. They know a familiar algebraic identity but do not notice it inside an unfamiliar expression. This is why reviewing only the final answer is not enough. Ask, at what moment should this idea have become visible? Reason 3 is strategy. Strategy is route selection and problem selection. Can the student tell the difference between a clean path and a brute force path? Can they use answer choices, estimation, symmetry, substitution, or a complement when those moves make the work safer? And can they leave a problem that is consuming too much time? Strong students are used to solving everything they are given. On AMC 10, that instinct can become expensive. Spending 6 minutes proving you can solve one difficult question may cost 2 easier ones. Skipping is not surrender, it is resource allocation. Classify this mistake. A student solves the product comparison correctly by multiplying both sides. It takes 90 seconds. Later, they rush an easier problem and drop a negative sign. What caused the lost point? The final mistake was execution. But the time pressure began with strategy. One question can have a primary and secondary cause. That is why right or wrong is too shallow for a useful review. Reason 4 is execution. Execution means the student found a sound idea but lost the answer while carrying it through. They read 14 as 41. They answered for x when the problem asked for x plus 2. They dropped a sign, skipped a case, copied a number incorrectly, or marked the wrong choice. Calling all of this careless hides the pattern. Where does the error happen? During reading, algebra, case organization, final verification, under time debt? Specific patterns lead to specific countermeasures. Imagine 3 students with similar AMC 10 scores. Student A has substantial gaps in geometry and number theory. Student B knows the content but rarely recognizes the structure. Student C sees the ideas but spends too long on hard questions and loses points through rushed execution. The same packet of 50 problems will not help all 3 equally. Student A needs focused content work. Student B needs pattern comparison and solution classification. Student C needs time decision making, problem triage, and execution safeguards. After the next practice set, review every missed problem and every correct problem that took too long with the 4-column audit. For each one, ask 4 questions. Did I know the mathematics? Did I recognize the structure without being told? Did I choose an efficient route and use my time well? Did I carry the solution through cleanly? Use a primary category and secondary category when needed. After 10 or 20 problems, the pattern will be more informative than the raw score. Start by using the 4-column audit on your most recent AMC work. If you want help interpreting the pattern, contact Princeton Academy through the link below and ask about current AMC support options. Bring the students' recent practice set, their written work, and if available, the time spent on each problem. That evidence makes the conversation far more useful than a score alone. The aim is not to complete the largest possible number of problems. It is to find the skill that prevents a strong math student from turning knowledge into contest performance. Do not prescribe more problems until you know what the last problems were trying to tell you.